Hello everyone. Today will be about suffering. We are solving LeetCode hard. I haven't solved this problem before, so let me just set timer for myself and let's go. Okay, so we are giving a string S. It contains parentheses and letters. And I need to remove the minimum number of invalid parentheses to make the input string valid, and return a list of unique strings that are valid with the minimum number of removals. And the answer can be returned in any order, so it will be a list of strings. Okay, let's think about tests. First thing that I'm thinking about is something as simple as this, right? So just to be clear, I think we should be returning just this one string, right? Then let's say there is also something like this. So I'm assuming this will be just a list of A. And if we have something more complicated, so let's say this will be that. Okay, let's now figure out how do we get different invalid strings. So for example, different invalid and multiple valid strings from the same invalid string. For example, one of the obvious ways to get invalid string is that we either don't have an opening or a closing one. Actually, let's make it simpler. So it's just that will again be the only possible valid string, and like however many of such strings of such parentheses we have, we always need to remove all the trailing ones on the sides. So then let's say that we have some sequence of strings like this, right? So currently it's invalid. Let's make it explicitly a string. But there are several ways to approach the removal of parentheses. Is there? Let me check. So let's make it a little bit shorter because it might be easier to reason about. So one way is obviously this. This is the first string. Is there any other string that can be created? Yes, I think so. So if we remove this one, we're also getting the correct string. Nice. So how did we decide? How did we figure out that there are two possible ways for this? So for any segment of the string that has an unequal number of opening and closing parentheses, we can match all the extra open parentheses. Oh, is it the only thing? Can we also? No, we cannot. Yeah, so we have this extra opening parenthesis right on the left side. So then we can remove one closing parenthesis from each of the sequences of closing parentheses, because if you remove any one from this sequence, you will get, like, if you remove that one or if you remove that one, you will get the same result, which is this result, which is, yeah, this result. Oh, actually, yeah, I was wrong saying that. So we are not removing this. We are removing either this one, right? No, no, no. We are not removing this. We need to remove opening parentheses because we have extra number of opening parentheses. Yes. So we calculate, like, there is a disbalance of opening and closing parentheses. So then for in each of the sequences of opening parentheses, we can remove one of those to calculate the final possible arrangement. Okay, so that means that my approach to solution would be find a balance of opening and closing parentheses, and then there will be either too many opening or too many closing parentheses. So the problem will be that there can be sub-segments of the strings with opening and closing parentheses. Let me try to figure this out. So can we create yet another string with like this disbalance? So what I'm trying to say, can it be that we have several substrings that we should be solving for independently of each other? Because I don't think so. I think you will be just, you just have to, so for all the parentheses that are looking like this, we are just removing those, and then we are left with some string. And then what would be the issue? So there are too many opening parentheses here. Is it always that we have to remove a specific one? I think yes. For example, here, right, we kind of have to remove this one because if we leave both of those, we can never create a valid sequence of parentheses, right? So that's the problem. We cannot just remove parentheses like, okay, let's first calculate the balance. So 3 closing, 1 opening, 1 closing, 1 opening, another closing, opening, opening. So I think it's 3 parentheses that we need to remove. Let's check. So for example here, how many parentheses do we need to remove? So we need to remove, let's say, first we remove this, and second we remove this. Is it the only way to remove that? Probably not. There is still this other way, so we can remove this one, but we still have to remove this one. Okay, so that's what I'm talking about. We have this substring, right, and this substring. And we cannot remove arbitrary parentheses. Can we also remove just these two? Yes, that's another way to remove this. Okay. So I think we can also remove, so we need to remove 2 opening parentheses. And the question is, how do we remove those? I will think about it for a second. Okay, I thought about this for a second. It sounds like we do have this substring idea that if we have an imbalance, right, and then there is like a bigger number of parentheses on one side than on the other. So we need to start from the side where we have less of such parentheses. I don't know if this makes sense, but essentially what I'm trying to say, we should start here from the right side. And then we are moving. And then what is the substring here, right? When do we have to remove one of the parentheses? We cannot just remove, for example, the first two opening, even though we have to remove two, we can remove these two, right? So it doesn't prevent us, even though those are in the same group, but we cannot remove these two because now the string is the resulting string is invalid. So how do we figure out what are the possible combinations where we can remove and cannot remove things? I have an idea. So when we start from the right side and go to the left, we should always keep the balance kind of positive. So if we get here, let's say we remove a parenthesis, right? This one. Okay, let's say we are starting from this one, and then the balance becomes positive, right? So we add +1 because there is one closing parenthesis. Then we move next, and it's a -1. So we are back to 0. We can try to remove that and continue iterating to the left. And then it's valid. But if we move forward and try to remove the next parenthesis, then the balance will be -1. And that means that we have skipped, so here we have to remove the parenthesis that creates a negative balance for us. If we don't do that, we can't move forward because we already have created an inconsistent string that we can never fix afterwards. Okay, so this sounds like a solution, an approach, an algorithm. I will summarize it now. So first we remove invalid parentheses on the sides. So second, start iterating from the side with how should I call it, negative balance, or the side that has smaller amount of parentheses. And then it becomes a backtracking problem. So we are trying an approach like choosing whether we want to remove this specific parenthesis or not. And then if we do remove it, we count the balance, and yes, we update the balance. So if we remove the parentheses, we move by one element, and we keep the balance the same. If we don't remove the parentheses, we move by one element and make our, like, if it's an opening, like a closing parenthesis moving to the left, if it's, we just increase our balance. But if it's a closing parenthesis, we subtract one from our balance. If our balance becomes negative at this point, we okay, if our balance is 0, we have to remove this parenthesis. We cannot move forward without removing this parenthesis. So we remove this parenthesis and then continue iterations. We just have basically one branch. So that's the idea. And we have two mirroring solutions, two backtracking approaches. Like, in one way we're going in one direction, in another way we're going in another direction. Then the question becomes how fast will be this algorithm. I think it will be exponential, because for each of the parentheses we are choosing whether we want to remove it or not, and theoretically there are many possible combinations for those parentheses. So it can be some long sequence. Let's say open and close, open and close, open, open, close, open, open, close, open, open, close. And then there will be a huge amount will there. So we always have to remove, yeah, I think let's also say that we have more closing parentheses here. So there will be, for many of those, for a big part of those parentheses, both adding or removing those will be possible options, which will branch this into directions. And overall it will be 2 to the power of n. Maybe a different approach to consider running time would be to, like, n choose k kind of thing. Like, we have some specific places where we can remove parentheses. How many ways are there to remove those parentheses? But I think this is a problematic approach, because our next decisions depend on our previous ones. If we have already removed enough parentheses, then we cannot remove more in this specific place. So sometimes in any of the substrings, sometimes we leave all parentheses, sometimes we don't. So I think it will be O 2 to the power of n algorithm. So now I need to figure out if it's a valid approach, and I will need to ask my interviewer how big is the string possibly. Maybe the interviewer would have already answered this before, already told me that. Yeah, so string length is 25. It's reasonably fast, it's reasonably short string, and I don't think that would be problematic. Then what is the space complexity? So we have the same amount of space, so there are many possible configurations for the strings that we are outputting, but this is not accounted for in our calculations. And the total space that we will need to do is backtracking. And in backtracking, we will have we will always be moving by one character at a time. So we will have only n recursive calls at most in our backtracking. Okay, so now let me do the implementation. Will this be an elegant solution? I think yes, why not? So I will do the q will be equal the q. Okay, 20 minutes have passed. Let's spend 20 minutes more. Double-ended q of string. Actually, I think, yes, I think we now will be treating overall symbols of the string. So now while dq and dq0 equals closing parenthesis, we do dq pop left, then while dq and dq minus 1 equals opening parenthesis, we do dq pop. Okay, so now we have removed all these possible parentheses. Oh yeah, actually, I have totally forgotten to consider what happens to letters that exist in between our parentheses. Yeah, I think it doesn't matter. So everything depends on, like the uniqueness of the string depends on if we remove a particular parenthesis or not. And it's unclear how exactly do we treat letters in terms of the validity of the string. I assume that, okay, I actually didn't explicitly assume that, so let me assume this explicitly, that something like this is already a valid string and it works. But I'm not sure if I should be assuming that. It depends on what we understand by valid string. Maybe this string is invalid. Maybe the letters should always be inside of the parentheses. So I don't know. Let me check, because this will be very important from the perspective of what are the valid. Yeah, this is a valid string. So everything stays the same. Letters don't change the solution. Okay, now we need to figure out which, how many are there of each parenthesis. So counter of dq, and if counter of, oh, I have a message in the chat. That's nice. Let me actually see what's written there. Hello. Hello. The Giant Slayer 911. We are solving a hard problem today. Okay, so if count this. Yeah, let me do that. I'm not guaranteed of getting this. I don't remember how exactly count works, but doing this explicitly is also always a nice thing. If count get opening parenthesis is bigger than count get closing parenthesis, yeah, let's say closer or equal. So if it's less or equal, we are starting from the left and moving to the right. Otherwise, we are starting from the right and moving to the left. So how do we define this? I will be equal. Yes, let me figure out what we have to define. So I direction limit. So if we are moving from the left to right, we will be encountering it will be going from one place to one direction and have one limit, and in reverse it will be a different one. I just don't want to implement this function twice in a mirrored way. And then there is also like opening and closing parenthesis, and we will be considering like if we move from the left to right, the opening parenthesis will be on opening one. But if we move from right to left, the closing parenthesis will be an opening one in a way. I hope that it's clear what we are doing here. So it's basically implementing the fully mirrored approach. So if this is smaller or equal, then we are moving from the left to the right. So I will be equal to 0 and direction will be equal to 1 and limit will be equal to length of dq, and I'm also thinking about like the finishing scenario. How do we decide whether we in the end add the string to the possible solutions? Is basically if we are pointing to the right to the limit. So limit I think will be length of dq minus 1 here, because this will be the final element. And if we are at this limit, no, let's actually make it this. So if we are at the limit and we have traversed the whole string, so if the balance is 0, then we have done the right thing and we can add this string to the answer. Otherwise, we cannot do that. And opening will be an opening parenthesis and closing will be a closing parenthesis. Else, it's the same mostly, but we will be moving from length of dq minus 1. This will be the first one that we will be considering. Direction will be minus 1 and limit will be minus 1 and opening will be this one and closing will be this one. Okay. Sorry. Yeah, now define backtrack. So we basically backtrack from this. Just let us be pedantic here a little bit and specify these things. So it's an integer, 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 and opening is a string and closing is a string. And we are not returning anything because we'll have an answer here that we will just be mutating from there. Answer is an empty list right now. Fortunately, we can remove or return those strings in any order. So now backtrack. Let's see. If I is equal to limit and yeah, there is another thing that we need to pass. Let me be okay. Yeah, this is not an ID, so I won't spend too much time. Sorry, I'm that pedantic. I cannot just not use pep8. Maybe I am wasting my time, but it's time well spent. Okay, there is also another thing, balance. We start with balance of 0, balance is integer, and we start with balance of 0, but then we continue moving on and on and on. And yeah, I can actually just refer to those things from the I can refer to these variables in the outer scope, and it's fine. They won't be changing when we are backtracking. The only thing that changes is I. And we always are defining this because we have if and else. So we shouldn't get any issues here. Okay, if I is equal to limit and balance is equal to 0, then we, oh, yeah, I also need to do current sequence, which is a list. And here we do answer, append, join current sequence. Okay, now if we are not at the limit, then we are either pointing to opening or pointing to the closing parenthesis. So if dqi is equal to opening, then balance plus equals 1, and current sequence. Oh, interesting. Actually, the answer will be different when we are moving from right to left and left to right. So if direction equals 1, so if we are moving to the right side, then resulting sequence equals this. Else, resulting sequence will be the same thing but reversed. First consequence. And answer will be appending resulting sequence. Yes, that's better. But yeah, it's tricky to implement it in both ways, in the mirrored way. Okay, so now current sequence will be append opening and backtrack I plus direction and balance. I actually don't need to do that. You can just do balance plus 1 here. Okay, else. So if the current parenthesis is closing, if we are already at a negative value, yes, I think we can just add another clause here. So if balance is smaller than 0, so if the balance is negative, we will never create a valid string anymore, so we just return. Then we have two choices here, right? So either we do, oh yeah, I also need to do, if this is opening, I need to, before returning, after returning, I need to remove whatever I was doing. Current sequence pop. So after I backtracked, I will be returning here, essentially, because this will be the last line of the execution. I can explicitly even return just to show what I'm doing here. So it means that we will be, like, if we are analyzing one possible branch, we will be doing a specific thing with this specific parenthesis. And then once we finish discovering this branch, we need to remove this parenthesis and return, because maybe in the previous branch we will be doing some other thing. So because if it's a closing parenthesis, there will be now two possible options. Yes, I thought that like if it's opening, we can try to merge those if and else's instead of three have two, I think, but I don't want to do that. I think it will be less readable, so I will just leave it at that. Then in the current sequence, I will do that. Okay, so now else, we know that now this is a closing parenthesis. So if we know we are at a non-negative balance, so we can just remove it. And if we remove it, we don't add it to the current sequence. That's it. So backtrack, I place direction, and balance, that doesn't change. So we just take one step. And then there is also a different option. There is option, we do that first, then we backtracked and we return. And here we have not added anything, so we don't remove anything. But then there is also another option. So after we backtracked, we do append closing, and then backtrack balance -1. And here we will be popping this back. Okay, yeah. So this is, as I said, right? Like in some cases for those like closing parentheses, we sometimes will be moving in two directions, and that's the example that I was giving for why it will be 2 of n, because n will be about like a third of all parentheses here, and n divided by 3 is still O of n, and 2 to the power of n divided by 3 is essentially still 2 to the power of n, because we try both of those directions. Okay, and then is basically return answer. Now I think it's clear that we are returning here, so let me remove that. Pen closing, pop closing, I plus direction, balance +1. Yes. How much time have we spent? Okay, almost 40 minutes. But this was a tough problem. And now let me actually try on this simplest possible parenthesis to see how this function will actually work. Okay, so we have this. We basically quickly decide that it will be this, because counter of opening will be bigger than counter of closing, so we will be moving from right to the left. So I will copy it again here, and oops, yep, I will be copying it here, and here I will also create a pointer just to show where we are right now in our backtracking. Okay, so we are here, and we start with balance of 0, and we are not at the limit, so we never go here. And if it's opening, then we just add it to current sequence. Yes. So current sequence will be, we're adding the opening one, this, and then we do backtrack and balance +1. So balance, balance, balance. Let me mark balance here. Actually, let's just mark it here. Balance was equal to 0 at the first, then at the second it will be equal to 1. So now it's still opening, an opening one. And for this opening parenthesis, we basically just move it once again, and we add this as another 40 minutes have passed. So we add it as another parenthesis, and here the balance will become 2. Now we move here, and now it's actually a closing parenthesis. And first we will try to just remove it. So we will move further, and removing this doesn't change anything, so we just do 3 for balance. And then we have 3 opening parentheses at this point. I'm obviously wrong with something in this discussion. So, okay, I try to not remove the first one, not remove the second one, not remove the third one. I get to the point where I just don't get the right balance. It will be the balance of 3. So then I try to not remove the first one, not remove the second one, remove the third one. And that would be basically this. We are adding the third one, then 1, 2, and oh no, actually, yes. If I'm not removing this, I'm not removing this, I'm not removing this, my balance will be at 0 in the end, and this will be one of the correct solutions. But since we are doing it in reversed, because direction is -1, so the answer will be appended with this. Okay, that's one of the answers. Nice. Now, whenever I consider removing this, right, okay, I first try to not remove those, that's fine. Then if I try to remove those, my balance will just be positive in the end, whichever one that I remove. And there is some repeated calculations here that we might be able to remove ideally, but I don't know how to do that. So let's go back here, right? So we tried to get here with balance of 3, and we had to leave all of those parentheses. If we removed even 1, we weren't ever able to get to the solution that we need to balance of 0. Actually, there is one optimization that I can think of that will just prune some branches. It shouldn't improve our running time, but we can calculate what is the total amount of closing parentheses until the end of the string. And if it's smaller than the balance, we can just prune this branch and never go in this direction. Should I do that? That would be fun, a little fun. Yeah, I think it will complicate the solution. Let's first ensure that it works. Okay, now we are at the point where we go back to this thing here, right? Because we first tried this approach where we removed it, so the balance didn't change. So we stayed with balance of 2 at this point, and then here we stayed with balance of 3. Now we are removing this parenthesis. Now we are not removing this parenthesis, so we are adding it here. So the current sequence, when we are backtracking, like for each of those opening ones or closing ones, we eventually backtrack to the situation where we have 3 opening, and then finally this situation. And here we are finally adding the closing one. So now we have a balance of 2 when we are looking at this. Do we though? No, yes, when we are adding this parenthesis, we have a balance of 2 because we have added 3 and we have removed 1. So the total balance will be 2. And then we just have a sequence of parentheses that we do like we will be iterating over those and try different combinations. And the problem here will be that we already have the resulting sequence in the answer, so we will add it more than once. That's the problem. We don't want to add it more than once, so we will just do answer equals a set. And instead of answer add, we will be answer, instead of answer append, we will be doing answer add. So whenever we add a new string, if it's already added, we won't be adding one. So will this change our runtime complexity? Yes, a little bit, because we will have to calculate a hash over a string of length n, and it will be of an operation. Or yeah, it's because it's a string. If it was an integer, it would be of one operation, but string is of an operation. So it will be 2 to the power of n times n, eventual runtime, but maybe it's n times 2 to the power of n with checking duplicated answers. Okay. Well, I think this solution is reasonable. I couldn't find any issues with that. It just doesn't output anything. It never outputs anything at all. Oh yeah, there is also another problem that I again forgot. We also have our characters. So for characters, if let's say if QI not in opening closing, then we just do current sequence append the Q of I and backtrack without changing balance. So we are adding it, so now we need to remove it once we return from backtracking. Pop. Elif. Okay, that's better. We have discovered one bug. It won't change much, so I'm not running this again. So what's the issue with my code? Why we are not adding anything to the answer? Is it some stupid mistake? Or so is it just some function naming or variable naming where we just don't use the right place to add things? Current sequence append, current sequence pop, so resulting reverse current sequence answer add resulting sequence if I is equal to limit and balance is equal to 0. That's a valid string. Oh, that was stupid. Yeah. It was a stupid mistake. I just never started backtracking. I wrote the function. I just never started the backtracking. Okay, let's call this start actually. Start. So I is this, and we just start at the start. And balance, we start with 0 balance. Okay. One valid issue and one stupid mistake. Double-ended queue. Okay. I have this limit. So it's strange. I'm not sure. Oh, yeah, I see. That's also a stupid mistake. I always assume that we need to return here, but I forgot to add the return explicitly. Again, under out of range. Actually, I just thought about one corner case. I'm not sure how this will work. Yes, my code won't work if here, if not double-ended queue, return empty list. So if we have removed everything, we are returning an empty list. But yeah, for some reason, we are getting incorrect direction. What is happening is somehow we get some integer I that is out of bounds for these dequeues, and it's still not the limit, which is strange. It was an issue that I encountered here. Like, one of the possible scenarios was that if it wasn't a valid string altogether, then we would just, we would encounter this issue. But the problem here is that we don't have an empty string here. It's actually a valid one. Okay, I figured it out. We are returning the limit if the balance is equal to 0 or not. If the balance is equal to 0, we are also adding the resulting sequence. So that's the issue. Oops. Yes, pop doesn't use any parameters. Okay, here I should be returning not this, but an empty string. I have a new chat message. How am I doing today? I'm doing mostly fine. Not great, to be honest. It was a long day. Wrong answer. Oh, yeah, that's another issue. Another corner case. That's where our parentheses start creating issues. Our letters start creating issues. I have never thought about this, unfortunately. And I should have, because I have a corresponding test case. Probably I should just try and check if all of my test cases are working before I submit the solution. Next time I will do that. So what do we do now? The problem is that in this scenario, we need to remove this parenthesis here because it's a closing one at the end of the string, kind of, but we cannot do that. So, okay, how do we go about this? There is an obvious way to do this, is like iterating from the left to the end of the string and only add parentheses related characters or letters, but until we see the first opening parenthesis, remove all the closing parentheses, and then do the same thing from the right to the left. But it's not an elegant solution. I would really like to find an elegant solution, but looks like I can't find it. So okay, let me create actually another subfunction here. Def preprocess string, and it will be as string, and it will be returning string, and let's also say direction. I will just rewrite code twice in this scenario. Okay, so okay. Scene opening false. Result is empty list. For character in S. If char is equal to opening, then scene opening equals true. Then if scene opening, then we just do result append character, else let's do L if. So we haven't seen opening and the character is closing. Okay, not equal to closing. Then we do that. Okay, now result equals reversed result, and let's call it intermediate result. And let's now create an actual result, which is this. For character in S. No, for character in reversed intermediate result. If okay, scene closing false, if close closing, scene closing equals true, and now basically that scene closing result upon care if join reversed result. Okay, so now we actually don't have a double-ended queue. But we'll still call it the queue. Self preprocess string S. Return this. Okay. Nice. Implementation just got even simpler. Use test case. Okay, yeah, I obviously forgot on self. Should I just read? Yeah. We probably should create a checklist on the end. Check the runtime of the algorithm, check all the test cases, and check the returning, and check the cells. What else should I check? Result, where it is not associated with the value. Line, this line. Intermediate result, obviously I should have changed this variable too. Let's try again. Okay, let's submit. That's interesting. My code is not processing this correctly. Why would that be? I'm too tired to try to debug this manually, so I will just first print DQ here and see if, oh yeah, I should do that, if we have the correct study out. Yes, this one is correct. So now let's see, we need to remove opening parentheses. Okay. if I goes to limit, print current sequence. Yeah, so we were moving from the right to the left, and it should be yes, it looks like my code is wrong. Oh damn, there is yet another scenario that I'm not considering. This is a tough problem. So the problem is that I assumed that I can just have this leak balance, and balance cannot go to negative values, but it can go to negative values. So I'm just, fortunately it's relatively easy to change. We just need to do this. Sorry. No, okay. Let me do this manually then. So we are kind of pruning things if we have negative balance, but it's fine. We just try all the possible combinations. Oh yeah, now we have many more scenarios where we are removing things, strings. Yeah, it doesn't work just like this. We actually need this code. Let's then look at this more attentively. I want to finish this problem. So the thing is that let's remove this M and let's remove this. We don't need that. We have more opening strings than closing strings. So we now not only need to remove the closing strings, we also need to remove the opening strings. That's actually the scenario that I was mentioning from the start. That is it possible that there are two substrings that we have to analyze independently of one another? And in this scenario, yes, because we are in the situation where we have many sequences that we have to remove in the center. And we have to review this sequence independently of this subsequence. So how do we figure out this situation and these subsequences? I think the solution here is basically you go from left to right and you keep balance positive, and then you go from right to left and you keep balance positive. And you do both operations. So you don't try to calculate the directions, you go through both directions. So if you do that, so for example, you go from right to left and you try to remove these two. So we have 1, 2, 3, 4, 5, and opening and 4 closing. So we need to basically remove 1. And this is not enough. So now there is an equal number of opening and closing strings, but it's infeasible. It's still invalid, but we still can remove more strings, can remove more parentheses so that it becomes valid. I'm thinking about one direction, which is to find a specific place, and from this specific place just remove those combinations of opening, closing and opening. But I don't even know how do I find this in my string. How do I investigate that we still have a problem? Let's say I'm solving a simpler problem. Just like remove the minimum amount of parentheses to make this sequence of parentheses valid. So now, whenever I go to the right, yeah, if I see a parenthesis that I have to remove, I just have to remove it. I go to the negative if I don't remove it. So if it's negative, I just have to remove it. Yeah, so let's think about this for a second. Let's say I'm in this situation, and in my solution I will need to go from right to left. And here I have balance of 2, and here I can basically remove those 2. And then I have balance of 0, right? And then I have balance of 1, 2, and 1. And I cannot create a string from here. But then I go from the other direction, and I start with balance of 0, and I do 1, yes, positive, and then I have to remove this. And I have to remove that. No. So yeah, I have the right balance here, right? No, not the right balance. I actually have this. Yes, and now the balance and then will be correct. But now I start here, and I get here, and I now need to remove that. But I never remove the other one in my current code. So if I go in 2 directions, I cannot create the correct solution. Okay, I have spent more than an hour on this problem. I'm too tired already. Okay, yeah, hour 15 minutes, still haven't solved it. We'll probably just review it afterwards, but thanks everyone who tried to look at it with me, and see you all next time tomorrow.